The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Problem 15 states a sinusoidal waves travel on 5 identical strings. 4 of the strings have the same tension, but the 5th is a different tension. Use the mathematical forms of the waves given below to identify the string with the different tension. In the expression, x and y are in centimeters and t is in seconds. Alright, so first thing you have to realize is that if a string having a different tension is basically the only way that you're going to have a different velocity in the string. So the trick is to figure out which one of these has a different velocity. If you figure out which one has a different velocity, which wave, then we know which one has a different tension. So if you can make that connection, then at this point all you have to do is figure out the velocity of each of these waves using the formulas that they gave you. So the formula of these waves is y of x in t is equal to h times kx minus omega t. Okay? So this gives you basically the vertical displacement of the wave at any given point in time and location along the x-axis, because these waves both move up and down as well as in the longitudinal axis. So we're not really concerned about what's going on over here. All we really care about is the velocity of each of the waves, since they gave us the formulas for them. And we know our velocity is just going to be equal to omega over k. And I know that's kind of a weird formula, but it's actually it's an important one when you're dealing with your waves. It's a nice one to keep on your formula sheet, or at least keep in mind. So since they gave it to us in this manner, then all we have to do is plug in the coefficients of x and t for each of these. So number 1 says y of x and t is going to be equal to 2 sine 4x minus 10t. So 4 is our k, 10 is our omega, then our velocity is just going to be equal to 10 over 4, which is equal to 2.5. Okay. Now, I'm not concerning myself over the units because all the units in this are consistent. They tell us, they don't even actually tell us what the units of k and x are. I'm going to assume they're in standard, but it doesn't matter. I know that they're going to be in the same units for each one of these waves, so I'm just going to compare all 5 of them. So our second answer, or our second option, x of t is going to be equal to 2 sine 2x minus 4t. Alright, so our velocity for that one is just going to be equal to 4 over 2, which is just going to be 2. So there we go, we already have our discrepancy. And if you're looking at the actual solution, the practice test, then you know the first one's going to be the wrong answer. So ideally, if we're doing this right, the rest of them should end up with a velocity of 2. So our third choice, 2 sine 6x minus 12t. So therefore our velocity is going to be 12 over 6, which is of course 2 as well. And keep going on in this problem, and you're going to keep getting to the next one. Says in our sine function we have 8x minus 16t, so 16 over 8 gives you 2. And the last solution is sine of 10x minus 20t, 20 over 10 once again gives us 2. Now there's a minus sign in this, which is kind of important with these waves. You have to keep that in mind. The minus sign should be in there. That means the wave is actually moving in whatever the positive direction is on your axis, as long as there's a subtraction sign. If this was an addition sign, kind of backwards logic with the way the formula is written, or the way the equation is written, so if this was an addition sign, then the wave would be moving backwards on the negative axis, whatever that direction tends to be, or is assigned to be, excuse me. That doesn't matter for this problem, because first off, they all have a subtraction sign in there, and they're all traveling in the same direction. Furthermore, they're actually just asking you to identify the tension, so the direction of the velocity doesn't matter. but it's a good thing to keep in mind. I've seen questions like that pop up on practice tests, so definitely important to keep in mind that the negative means it's traveling positive on your axis, and a positive here actually means it's traveling in the negative direction on your axis. So, sum it up. This tension, different tension in a string causes a different velocity. This is your velocity formula for a wave. Just keep in mind which coefficient is which and solve for all the velocities. Figure out which one stands out as a different velocity.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.